Hello, everyone. So here's Peter Xu speaking from Auckland, New Zealand. And it's midnight here. And hold on. Okay. So in the next few minutes, I'm going to give you a brief introduction to our research program on digestion robotics. So here, digestion robotics are our research ambitions, and started around 20 years ago. Human digestion involves organs from mouth where the food gets in, through the esophagus, stomach, intestine to the anus where food waste gets out of bodies. So in terms of robotics, digestion robotics studies cover both rigid body robotics, that is human masticate systems, that is break down foods into the particles, and the soft body robotics for the rest of organs, which involve no skeleton. So we are a multidisciplinary team in New Zealand. We have members from engineering, food science, pharmacy and medicines. So our research has been continuously funded by two centers of research excellence in New Zealand, so which is the Reed Institute, specialized in the foods and nutrition, and the Medic Technologies Center of Research Excellence. Why digestion robotics? Generally speaking, we aim to develop robotic instruments that are able to mimic and simulation digestion process, physiologic, pathologic conditions, and the interaction between organs and the food, drugs, implants for purpose of various measurement. So these robots have been found good application in R&D in the foods, drugs, medical device, as well as personal medicines. So 20 years on, we have developed a few generations of variety of robots, such as masticate robots, robotic tongue, robot esophagus, robot stomachs for those organs. Today, I just show you two examples of digestion robotics. The first one, the esophagus robot, which is in the context of soft robotics. The biologic structure of the human esophagus can be regarded as a hollow, cylindrical musculature, involves longitudinal muscles, the circular muscles, mucosal layers that interact with the food. So when humans swallow a food bolus, the condylar lumen contracts so that the deformation wave is generated, which travels in the condylar of the esophagus. So by means of the traveling wave, food bolus is pushed from up esophageal sphincter to a lower esophageal sphincter. So that the traveling wave can be described by a special temporal functions, so that these functions serve as a requirement for the development of a robotic esophagus. So that robots will be able to deliver these mathematical functions. So when the wave travels in the condylar lumens, a pressure is generated at the tail of the food bolus. So which is served as secondary requirements for development of the esophagus robot. So basically, the robot is to deliver two mathematical equations. ROSE, robotic soft esophagus, is a name we gave to the esophagus robot we have developed. Body is made from the silicon materials. So, and the body is broken into 12 layers. So each layer have a 4 chambers. Okay, therefore a total of 48 chambers are embodied. So at any time, only 3 layers of chambers are pressurized, so that co-actuation of the pressure chambers travels from one end to other end of the esophagus. So therefore, the robot we built is a pneumatic operated soft robot systems. The ROSE is able to generate the wave that have different wavelengths, traveling speed, and amplitude. We have found a number of good applications. So the application I'm going to show you first is the in vitro simulation of foods and the drugs. So in vitro testing of the food rheologic properties for the purpose of dysphagia management. So dysphagia patients has difficulty in swallowing foods, so that the modification foods is one of the management methods in clinic. And we also use the ROSE to perform in vitro testing of abuse deterrent formulation opioid drugs, to look at the swallowability in terms of transit time of the tablets. So the ROSE in this image is placed in the standing positions. The food drugs are fed into the robot from the funnels, and they travel all the way upwards. So by means of upright standings, so we're able to avoid the gravitational effect. So it's a real setup in the lab. So we can see we use some manometers to measure the pressure profile when the bolus is being transported. Second examples, the ROSE is used to testing the stems, esophagus stem. So this is stem, the implant in the human bodies. It moves during the time. So for the optimal design of stems, so we need to perform tests and the different operation conditions and the different food bolus and the different lubricants applied. So this is a setup, the way we perform stem migration test. Okay, so in this experiment, the ROSE is placed in the horizontal way. For more details about the ROSE, its design modeling principles, the machine learning approaches, you can read those publications were made. Most of publications published in IEEE journals and soft robotics. So on the topic of ROSE, we have educated 6 PhD students so far. So second example of soft digestion robotics is a robotic stomach. So if we look at the biologic stomachs, it involves the 3 portions. One is the fundus, middle part of the stomach is entrance, and this part is a parose. So the behavior of each part is a little bit different. The fundus just perform the tonic contraction, 3 cycles per minute. So middle portion, the wave is generated by pacemaker located somewhere here. The wave, in terms of 3 cycles per minute, travels across the bodies. And this the pylorus is just for serving as valve, open, close, and to let the content to be released from the stomach. So based on this understandings, we can prescribe the technical requirement for robotic models. Okay, so we prescribe the different level of contraction at the fundus and the different level of contraction in the atrium and the full occlusion at this segment of the stomach. So this is a requirement. Then this is the results. The first results.
Peter, can you wind up?
Okay, so we made the 2 versions of stomach robot. One is Surrogate in 2019, and we got another version of the robot stomach Soros, 2021. So if you want to know more details, or research on the soft robotic stomachs, you can go read our publications published in Attribute Transaction and the Soft Robotics. Okay, thanks for your attention.
Great, thank you very much. Our last speaker is Darwin Lau. He's going to talk about robotics for smart construction.